Hello judges and fellow participants, my name is Sumit Chaudhary and this is my project for CQHack25. My project name is QQR Quantum Powered Drug Interaction Predictor. QQR Quantum Powered Drug Interaction Predictor, it is a quantum classical hybrid application that predicts potential drug-drug interaction by simulation molecular similarities using quantum circuits. Let's see the problem statement of this. Adverse drug interaction are major challenge in healthcare. Due to this, many patients are hospitalized and experience harmful drug interaction. Existing tool rely on manual checkups and classical simulation. Molecular behavior is complex. Classical model often fail to catch the subtle risk. This is where the QQR leverage the quantum similarity to solve this. Let's see how QQR works. From user, we take two drug molecule inputs to predict the reaction of those. I have used RDKit to extract molecular descriptor, that is molecular weight, log P, and H bond, donor and acceptors. And I have used quantum layer, that is Qiskit of IBM, to get the encoded feature of molecules into via ZZFeatureMap and simulate quantum state vectors. From these, the fidelity calculation is done, and by those calculations, we predict the risk interpretation, and that's how it's done. Let's see what makes it quantum. This isn't basic classical machine learning model pretending to be quantum. We used quantum circuit encoding, quantum fidelity calculation, optional execution of IBM hardware, and what are the bonus features I have added is PubChem API integration, and I have also added benchmark quantum versus classical similarity function to validate this approach. Let's see the live demo what I have made. I have done in the VS Code this project, and let's see the live host. This is my project. On the left side, you see a configuration section. There is a checkbox. If you want to use IBM quantum hardware, you can click here. And below that, there is a section where the information about QQR is written. On the left side, there is a two section, drug 1 and drug 2, where user input the names of two drug or smiles of the drug. Let's see with this example and predict the information. First, it will show molecular information, molecular weight, log P, and donors and acceptors and their diagrams. Below that, you will see quantum chemistry analysis and their results. What is the energy of drug 1, drug 2, and what are their interaction? If the interaction is more than 0.5, it will show high risk, strong binding. If it is below minus 0.5, it will show low risk, and if it is 0.2 or more, it will show normal. Below this, there is a section called technical detail. In this, it shows quantum computational detail, what is the method used, what backend is used, molecular encoding, feature encoded thing, and then the energy components in heart rate units and the interpretation. This is the local host. Let me show you the Streamlit, which I have done. I have deployed this project. Let's take a live example from PubChem. Let me take a smile name of two chemicals. CLOK. Let me put here the names. Let's predict the interaction of these two drugs. Here comes. It shows a moderate reaction because it is below 0.5. And here is the technical details. These are the reaction. If you want to clear this, you can simply click here. It will click clear all the thing. You can use quantum. Here are quantum hardware. Here are other examples you can use. By clicking here, it will change. Sorry. Also, you can write names. Let's take water and glucose to check what is their interaction. Let's predict. Oops, sorry. Water and glucose, right? Will take some seconds. Here are the information, molecular. Here is the result. It's below 0.5 and moderate risk. This is the project QQR. Now let's see the future scope, which I decided to do this with this project. With this project, I can add quantum SVM, that is quantum support vector machine, for classification. Also, we can expand it to a multi-drug. For now, it is only two drug interaction. In future, we can use it for multi-drug interaction, and by that interaction, we can predict the side effects, what are the targeted toxicity, and also provide the more descriptor via quantum feature map. This is QQR, bridge between quantum computing and real world. Thank you for this opportunity.